Earth Science, Chapter 6, Section 9, Using and Conserving Water. Digging deeper. Freshwater use. Types of water use. Figure 1 shows the sources and uses of fresh water in the United States in 2010. The amounts shown are in millions of gallons per day. Total withdrawal from all sectors amounted to about 355 billion gallons per day. Thermoelectric is the largest single use of fresh water in the United States. An estimated 161 billion gallons were used in the generation of electric power from power plants every day in 2010. The second largest single use of fresh water in the United States is irrigation. An estimated 115 billion gallons were used for watering crops every day in 2010. Irrigation and thermoelectric use make up 77% of the daily demand for fresh water. That is why it is important to develop methods of irrigation that minimize consumption. Public supply implies a mix of water uses including domestic, commercial, and industrial. It also includes water used for public services such as street cleaning, firefighting, public facilities like swimming pools or fountains, and supply to public buildings such as a city hall or municipal museum. Domestic implies water used in homes. Industrial implies water used in the manufacturing processes. Thermoelectric implies generation of electricity by oil-fired, coal-fired, gas-fired, or nuclear-powered power plants. Almost all of this water is used for cooling the steam that is used to produce the rotational motion that drives the electrical generators. Most of the water is said to be self-supplied. That is, it is taken from special reservoirs or wells connected to the power plant rather than from municipal supplies. Also, most of the water is returned to rivers, streams, or the ocean warmer than before it was used for cooling. Irrigation implies water that is applied by an irrigation system to assist crop and pasture growth, or to maintain vegetation on recreational lands such as parks and golf courses. Mining implies water used for the extraction of naturally occurring minerals, including solids, liquids, and gases. Livestock implies water used for livestock watering, feedlots, dairy operations, and other on-farm needs. Aquaculture implies water use associated with the farming of organisms that live in water, and off-stream water use associated with fish hatcheries. Consumptive use versus non-consumptive use. Most of the water use shown in Figure 1 is non-consumptive water. It is water that is returned in liquid form to the natural environment after use. Some non-consumptive water goes into rivers, lakes, or the ocean. Some soaks into the ground. Almost all the water you use in your home is non-consumptive. Think about what happens to water used in bathing, clothes washing, and toilet flushing. It goes either into a municipal sewer system or into a home septic system. Consumptive water is water that is returned to the atmosphere as water vapor. Some of the water you drink is returned to the atmosphere by breathing and perspiring. The portion of water used on lawns and gardens that evaporates before soaking into the ground is also consumptive water. Trends in water consumption. Figure 5 shows trends in water use in the United States between 1950 and 2010. Total withdrawals for all types of consumption fell by 13% between 2005 and 2010. This was caused by a reduction in water needs for thermoelectric power, irrigation, public supply, and industry. Thermoelectric withdrawals alone decreased by 20%. Mining and aquaculture had larger withdrawals within 2010. However, overall these categories were relatively small. During this same period, the United States population increased by 4% or 12.3 million people. There are several reasons why thermoelectric withdrawals decreased despite the increase in population. First, natural gas has increasingly replaced coal as a fuel source. It requires less water for cooling. In addition, new technologies enable water to recirculate through cooling systems. This reduces overall usage. Also, some power plants have switched to air or dry cooling. This also saves water. New regulations to reduce the impacts on aquatic life by restricting water use may also have had an effect. From 2005 to 2010, irrigation withdrawals fell from 127 billion gallons per day to 115 billion gallons per day. This is a reduction of 9%. The total irrigated acres were 2% more in 2010 than in 2005. These changes are due to the use of more water efficient irrigation systems. For example, there has been an increase in the use of water efficient sprinkler systems over flooding irrigation surface methods. Reducing wildlife impacts. Federal and state agencies focus on reducing the hazards to fish and wildlife from withdrawing water from rivers and lakes for cooling thermoelectric power plants. There are several ecological risks. Intake screens keep debris in the water from entering the plant. Smaller fish and other aquatic life may be drawn through the screens. The early life stages of fish and other small aquatic life, such as eggs and larvae, are most vulnerable to passing through the mesh of the screens. Larger organisms may become impinged on the screens. Another threat comes from the discharge of cooling water. The water that is released back into rivers and lakes can be 10 to 20 degrees Fahrenheit warmer than the water that enters. Than the water it enters. Warmer than normal water can kill fish, block fish migrations, and cause the growth of nuisance species that change the natural ecology. This process is known as thermal pollution. The Federal Clean Water Act requires that the Environmental Protection Agency makes sure that power stations use the best technology available to reduce these as well as other environmental impacts. Water conservation. As you learned, there are common ways to increase the water supply. For example, dams and reservoirs can be built. Another way is to transport water from one place to another through aqueducts. Groundwater sources can also be developed. In many parts of the country, however, the water supply cannot be increased as fast as the population and demand for water grows. In communities where new water sources are limited, it is very important to conserve water. This will become more and more important as the years go by. The water supply is more abundant in the United States than in most countries. However, conservation programs are important in the United States as well. People can save water at home in many different ways. Use of low flush toilets, low flow shower heads, and faucet aerators conserves water. Faucets with motion sensors ensure that the water is turned off when no one is using it. These are useful in public washrooms. In agriculture, farmers can conserve water by using drip irrigation for crops. Traditional methods of irrigation are very inefficient. Much of the water evaporates in the air. A lot of water also soaks into the soil between the crop rows rather than being delivered to plant roots. In Figure 6, in a drip irrigation system, water flows into main tubing and then into smaller tubes that branch out along rows of crops. In drip irrigation, water is supplied slowly to the soil through special piping and tubing. The piping or tubing has many small holes. The water drips or oozes out around the plant roots. Xeriscaping is an excellent way of saving water in cities and towns in arid regions. Xeriscaping means landscaping in a way that uses as little water as possible. It involves using plants that are naturally adapted to the climate of the area. These replace plants like grasses, which need frequent watering during hot, dry weather. Figure 7 shows an example of xeriscaping. Other ways of conserving water and landscaping is to use mulch around the bases of plants. Drip irrigation can also be used in xeriscaping. Figure 7 shows landscaping with plants that require little water. Plant roots help to aerate the soil and bind it together, increasing infiltration and reducing erosion.